in 80 weken, 560 dagen en totaal 6 digitale meetups. Leuk om te zien dat iedereen zo met vol enthousiasme is gekomen en lekker aan het socializen is. We hebben vandaag 2 sprekers. De eerste is Tim van der Keer. Ja, dat werkt niet als ik dan wijs tegelijkertijd. Hij gaat het hebben over data engineering en waarom het eigenlijk superleuk is en jullie het allemaal moeten gaan doen. Daarna hebben we een kleine pauze waar jullie een kwartiertje hebben om wat te drinken te pakken, even na te praten. En vervolgens zullen we Gert Hengeveld hebben, die gaat hebben over Storybook. Daar is Gert. Hartstikke leuk jongeman om mee te praten. Ik heb alleen niet echt heel veel verstand van front-end engineering. En wat zeg je? Ook niet. Nee, helaas. Maar ik bluff me er goed doorheen tot nu toe. Dus, na de tweede talk zullen we even een moment hebben om met elkaar na te praten. Wat te eten, wat te drinken, een biertje te drinken. Nou rest mij nog te vertellen dat wij onze volgende meetup is 2 december. Die zal plaatsvinden in Utrecht. En daar hebben we 2 talks en die komen morgen online. En de meetuppagina, dus hou die allemaal goed in de gaten. We zijn bezig met een Slack-kanaal op te richten, dus een community waar je van tevoren vragen kan stellen aan de sprekers. Zodat die dus mee kan nemen in zijn meetup en ze goed kan behandelen, waardoor je geen ad hoc vragen hebt. Daarna zullen daar relevante content gedeeld worden, naar aanleiding van waar er over gesproken gaat worden. En krijgen jullie inspraak in waar wij de toekomstige meetups over gaan organiseren. Zodat wij nog relevantere meetups aan jullie kunnen aanbieden. En natuurlijk kunnen jullie met elkaar in discussie gaan over dingen die zijn besproken. Nou ja, dan Tim, take it away.
Okay, I did give some talks in the meantime from the comfort of my desk, but this is pretty special. So, what even is data engineering? Let's find out. Who am I? I'm Tim van der Keer. I am a DataOps enthusiast, and this basically means that I like working with cutting edge data technologies. I like working with people who work with data. Because I believe that only together we can build better tools and better tech stuff. And that's what is very prevalent in DataOps. I also more formally do Dev and DataOps at FullStack, and FullStack is a wonderful company here in the Netherlands doing all kinds of cloud native stuff, microservices, Kubernetes architectures, and everything that runs on top of Kubernetes. We're a bunch of nerds. We grow really fast. Last time here at DYJ, I had the full posse, the full company with me as well, which was like 5 guys. Now we are 40 guys, so I couldn't bring anybody along. Also, I'm a proud member of the Data on Kubernetes community. This is a community for the betterment of data on Kubernetes. People might think you cannot do data on Kubernetes, but you can, so it's not just for stateless workloads. It's very cool community. Check them out if you like doing Kubernetes stuff. And now on to the good stuff. So, what did I do for these past 3 years? I figured out what data engineering even is, because up until 3 years ago, I did not know. Basically, there was a problem at one of our clients. They had problems with the data pipeline. I did DevOps, and they contacted me, hey, can you help us out? And I basically turned this into this. And along the way I figured out what data engineering even is. So the problem that they had was they had a data pipeline that was ingesting data via a Python application running on a virtual machine. That data went to an internal data warehouse. That data then went to another server that did something with R, and then that data went to another data warehouse, BigQuery. Was error prone. There was no version control whatsoever. There was also no quality assurance. Lots of things were wrong with it. Lots of things that I knew how to fix because this was all DevOps stuff. But I did not really touch upon the data engineering specifics, or basically moving the data around. And then 3 years later, we turned it into a nice data platform with all kinds of data engineering goodies inside. This is actually already a pretty old slide from I think a year ago, and nowadays our ecosystem is much, much wider already. We also do machine learning now. We have also data platform components on Azure. So this is just a small bit. So I want to show you guys and gals a little bit what you can do with data engineering, or some use cases in which data engineering is a pivotal part. And the first one is pretty boring, personally. It's dashboards and reports. So we need data engineering here to make sure that we have correct data available to do analytics for dashboarding and reporting. So we have source systems, then we have something in between, which is data engineering, and then we have dashboards and reports as output. Pretty boring if you ask me, but what's more cool is that we can also do more interesting things where data engineering is an enabler. And one of the things here is, for example, automated product rank listing. And what we try to do here in this use case is we try to change the way products are shown to our end users based on certain data in our system. For example, we might have different products of the same type, but they one has a higher markup, so higher revenue for us, but maybe it's a product that our customers don't like seeing. Then using some analysis, we can get a data set that, when fed back into a search engine, relists where certain products are without actually giving that our customers a bad idea that they are seeing a product that they don't want. And they actually get shown a product that gives us a higher revenue. This interaction from the user with this automated product ranking also turns back into a new data set. That data set feeds back into our system. That gets used for analysis again. That gets shown to our end user. The end user interacts with that, and that feeds back into a system again. So we get an automated system doing analytics, which generates value immediately. And then the third use case is continuous machine learning. So here also we need data engineering. We need data engineering to be able to supply correct and reliable data to a machine learning algorithms so they can make the correct forecasts. And an example of this could maybe be maybe we measure how many people are in a certain street, like with the corona things, and then we correlate that with maybe some weather data and maybe some public holiday data, and then we try to make a forecast. Hey, how busy is it going to be in the street? Do we want to use 1 meter, 2 meters, 3 meters, 4 meters distance? So we try to forecast based on that. And for that, for our algorithm to do that, we need to feed it correct data. Because if we don't feed it correct data, we'll get the wrong forecast and we'll take the wrong actions. So that's pretty cool. Continuous machine learning, automated product ranking is also pretty cool. Dashboard and reports, it's kind of a given when you have data or want to do analytics. So what data engineering does is it enables generating value from insight. That's what data engineering enables. It enables good data so that people can do analytics, so that people can create insight, feed that back in our systems, create value. And I kind of envision it a little bit like this. Like the house of data, where we have a bottom layer, which is our infrastructure. We have 3 pillars, and then we have the roof on top. And this translates to this. So we have one pillar, data sources, generation, which is all of our raw data sources, or maybe not just raw data sources. It's basically just data sources. So data sets in databases, raw files somewhere, maybe on somebody's hard drive, logging and metrics data from our applications and the services in our landscape. These are all examples of data sources. And then on the other end, we have insight creation. So usually BI, business intelligence specialists or data scientists will use our data to create insight, to create new data sets based on a SQL query. Maybe they will use some Python scripts to do some analytics. Maybe they'll create a dashboard, who knows, right? Maybe they'll use Excel and CSV files. God forbid, I can't even say CSV files, so hard. And then in the middle we have data engineering. And data engineering is what ties this together. So data engineering enables that we get the correct data available for generating insight. And if one of those pillars fails or does not work correctly, we have no insight, or maybe we have insight, but we do not have the correct insight. So we have unreliable insight, and then our house comes tumbling down. And if we don't have the correct systems in place, we won't even know that this is happening. So what hurts? From an end user's perspective. So from an end user's perspective, when living in a data world, it really hurts to not know what data is out there. So they don't even know what data to use to get to a certain analysis, to a certain insight. Maybe they'll have to ask around, hey, do you know if this and this data is there and if I can use it? And then that person will say, oh yeah, maybe you should talk to that guy, and then that guy points them to somebody else, and then that somebody else is no longer working for the company, and the knowledge is gone. Not knowing what data means. So maybe the data is there, but it's just numbers, it's just strings with some fields, with some columns. There's no descriptions, there's no description about the data set as a whole. Nobody knows when it was last updated, if it's even used anymore, if it's even relevant. And this really hurts, because we cannot create insight when we don't know what data means. And the third one is data being unreliable. So it's kind of a culmination of the top two, right? Data is unreliable when we don't know where it is, when we don't know what it means, when we don't know if it's still used, if it's still updated. This really hurts from an end user perspective. This sucks. This is what we have to solve using data engineering. What hurts from a data engineer's perspective? It's the same thing, because this is the problem we are trying to solve. We need to supply reliable and meaningful data for our end users. So personally, if I don't know what data is in my system, that hurts me. If I don't know what data means in my system, that hurts me as well. I mean, I don't even know how to use it, because I'm not an analyst, I'm not a data scientist. But if I don't know what data means in my system, that just sucks, because I don't have a describing system. And data being unreliable kind of speaks for itself. Of course, there's many more things that hurt a data engineer. CSV files, CSV files, CSV files. Who of you uses CSV files? Stop using CSV files, use something else. Okay, so the power of data engineering, this is like the power of data engineering comes from being able to supply reliable and meaningful data in a correct and timely manner. If we do this, we are good. This is what we need to do. So let's fit data engineering into these use cases. Dashboard and reports, this is like the base thing. This is the thing we start doing when data engineering, when we don't have dashboards and reports and data engineering in place. we want to create dashboards and reports. And this is what we need to do. So we need to ingest data from source systems, then we need to clean and enrich that data so that we can use it for analysis. Then we need to catalog and describe this data, and then we need to make data available. This is the base of what we need to do to get to dashboarding and reporting. And I did not put dashboarding and reporting in here because that's not really a data engineer's task, at least not mine. I don't know anything about creating dashboards, well, maybe a little bit. But I'm not a data scientist. I care about these things. But yeah, also, what I think personally is really important, that we try to build tools so that end users can do the above things themselves. So that if there's maybe an interesting piece of data they want to ingest, that they want to clean, that they want to transform, they can do that themselves. And of course, this changes varying on the degree of skill and the type of end user you have. But let's try to enable people to do the things themselves, right? Otherwise, they always come to you with silly little things, which they might be able to do themselves. So the first step, ingesting data from source systems. Here we have an example of raw data. So we have here raw sales data, and we have here some Google Analytics data. I don't even know if this is correct Google Analytics data, but I think it is. Is it? Does anybody know? No? Okay, well, let's just assume this is correct Google Analytics data. So we have our raw sales data, we have a customer ID there, and we also tag the customer ID in our front end if a user has logged in, so we can track whatever he does on the front end. And then we ingest this data and we output it into our data warehouse. Something we also do is we cleanse data. So we make, we ensure that data adheres to a certain standard that might be useful or valuable down the line for our analysis. In this case, maybe we sometimes don't have a customer ID because it's an unknown customer, but the customer is not logged in or registered in our system. And we don't care about records where we don't have a customer ID because we cannot use it for some analysis that we want to do. So then we cleanse those records from our data, and then this becomes a new data set. So cleansed sales data. And this also goes into the data warehouse. Next up, we have enriched data. So we first have our cleansed data, and now we want to enrich it. We want to enrich it with our Google Analytics data so that we get a data set that is ready for analysis. In this case, we want to track or do analytics on sales from advertising. We have this advertising data from our front end, from our Google Analytics. We add that data based on customer ID to our cleansed sales data, or we create a new data set derived from those two. And now we have a data set that we can use for maybe tracking if users, via which ad campaign users come in, and if they are often or if they are not hitting products in an ad campaign when they are maybe in their basket or in their sale. Next up, we catalog and describe this data. So for me, it's a thing that is often overlooked, but it's the most important thing in data engineering. It's describing what the data means. So what does a data set mean? What can you use it for? Where does it come from? When was it last modified? What kind of data is it? Who is managing the data? Who is owning the data set? So in case you do need to ask somebody, you can go directly to the correct person or the correct team. Also document your model. So what are the columns? What are the fields? What are their types? And not just the types, but also what do the fields mean? So if it's a sales type, it can only be one of online, offline, or a side hustle. And you can also use this further down the line for automation and for data quality testing. If you just put this information in your model, if you just describe what your data is and what your data means. And we put that in a data catalog so that other people can find data that they need in our systems. And then the last step here is to make this data available to our end users. And how do they use it? That's how you supply it. That's personally my opinion. If they want to use a certain dashboarding tool, if they want to have a data set, the data set in SQL, if they want to have, God forbid, CSV files, then you supply them CSV files. So a stream of data that they consume, if they want to have a data stream, even though it's not really useful because it's batch data and it comes once a week, if they want to have it in a data stream the moment it arrives, then you just do that. That's my point of view. Try to make it simple for your end users. Next use case, the automated product rank listing. So here we do all the previous steps. That's the base for our data engineering platform for the thing we do in data engineering. And what's different here is that a data scientist or analyst then creates insight that feeds back into our systems, in this case our search engine. And then the interaction from our end user with this generates a new insight, a new data set that feeds back into a system that we use again in our analysis so we get an automated system. And we run this analysis every night, we output it, and then we load it into the search infrastructure like I just said. And for this we use a data workflow. So a data workflow is the steps we need to take to get from point A to point B. So which source data we need to ingest, what we need to do with it, do we need to cleanse it, do we need to transform it. Then maybe we have a bit of analysis, so then the data scientist comes in, they say, hey, I have this Python script or this SQL query that generates this insight, and then we add that to the workflow as well. And then the workflow is what we interpret and run. Usually a workflow, it's not always the case, but what I find out is that usually it's configured using programming language, Python in our example. But a workflow could be as simple as just some bash commands tied together. Those can also be steps in your workflow. Take a file, process a file, output a file. That's already a data pipeline. That's already a workflow. So in this case, we check if dependencies are met. Is our raw data available? Is it up to date? So are we using the latest data for our analysis? Then we run the analysis, so whatever the data scientist provides, SQL query, Python script, whatever. Then a very important one, which is not really standard in data engineering, but should be, is testing the output. So not just testing the components of our infrastructure, testing our code, but also testing what happens in the data. So in this case, we probably have the data scientist. They know what the output should be like. They know certain KPIs, and they should log those KPIs for us, so we can build tests around them. So whenever we run this analysis, we know if it's correct, so we don't feed unreliable data back into our system. And this nearly never happens, which is really stupid. Then we write the output to a data set, and then we upload that data set to our search infrastructure. And then the next day, we do it all over again, automated. Next use case, continuous machine learning. So I'm only going to touch briefly upon this one. It's a lot of the previous steps. Again, who would have thought? But now our analysis algorithm trains itself based on good, clean, usable data. So again, we made the data available in a reliable and correct way, so that the algorithm that was developed by a data scientist can continuously train itself on correct data. Because if we do not do that, and if we do not have quality gates in place to test and verify that data, we get crap. We get a forecast or an output or prediction from a model that we don't know is correct. It might look correct, but we can't validate that that is correct. We need to validate for every step along the way. So data engineering is really important here. Again, good, clean, usable, and reliable data. That's what our model needs, so that is what we need to provide. data engineering tools is the next section. And I just briefly want to touch upon some of the concepts of things you've already heard me talk about in other slides, like data warehouse, data workflows, stuff like that. I basically want to touch upon some common core infrastructure components, the concepts around them, so what they mean, what you usually encounter, so what is a data warehouse even, right? So it's just really big database. That's what a data warehouse is, and it's a core component of data engineering infrastructure. It usually works with SQL, some other kinds of relational data, and where this differs from a transactional SQL database that you would use for making quick changes to records, making quick changes to tables, and then providing the output from that back to your end users with low latency input. That's not the case here, because we have very large volumes of data that we want to churn, that we want to run analytics over. Could be terabytes or more and more and more, so we don't have this latency for our end users. But that's becoming more and more important to do this analysis as fast as possible. And that's also that you see with the major cloud vendors, they are all separating compute from storage, so that you can basically run your analytics faster. You can scale out the compute, depending on the kind of query you are running, so you can get your output, your insight faster. And this is, I mean, the major cloud providers are already front runners in this, but this is going to be the new standard. Databases where compute is completely separated from storage. Then we have the data model. So the data model is everything describing a data object in our system. It's a centralized place where we describe what a data thing looks like. What you can use it for, where it comes from, how it is created. Maybe it is the definition of a table in your data warehouse with a schema and a description and an owner, and maybe also the steps you need to take to build the data. And the model initially, at least that's what I think, is for people to interpret. So maybe this also has a certain definition of what revenue is for you or for your company or for your business. So it's for people to interpret. It's also good for in the data catalog, but it's also an entry point for further automation. So if you have something that is describing what a data object looks like, what the steps are you need to take to get to the certain data object, then you can have your systems interpret that model and then build the data pipelines themselves, build the data objects in the database itself, build the tables, output data about it to the data catalog. So it can serve as an entry point for building the data objects in your system as well, not just describing them. Next up, data pipelines. And I put data pipelines here, but it's also a little bit data workflows. So it's basically the steps to get your data from point A to point B. And the data pipeline is usually the thing, it's like the runtime environment, the thing that actually runs is the data pipeline. Yeah, so basically it's also the steps you take to get from point A to point B. The data pipeline can be very simple, can also be very complex. Yeah, data lake. That's also interesting. It's a large volume of data as files. So we might not only have relational or structured data, we might also have video images, video files, images, maybe some audio files, all different types of data, structured and unstructured. And we also need a place to store them. And this comes in the form of a data lake. And the data lake is basically blob storage on which we store files, and then we have an abstraction layer on top of that. And this abstraction layer provides us with indexing, with search, and maybe also query functionality and some other metadata that describes the files, that generates a certain standard on top of them, that makes it easy for us to find the data we are looking for. What's also nice is that with a lot of the current data warehouses, you can have your files be the source of your tables. So you can make a sort of a managed table in your data warehouse based on files in your data lake, so that you can use the power of your data warehouse for doing queries and analysis, but still have the scale out flexibility of a data lake of just files on blob storage. Workflow Orchestrator, also very important. This is what actually runs the workflows, runs the data pipelines. Runs them every day, runs them every week, runs them once a year, runs them maybe continuously. And this workflow orchestrator interprets our workflows, spins up our data pipelines. There's usually also a little bit of monitoring and logging around it. So anything that I as a data engineer would need to monitor and manage the flow of data in my system, that's usually in the workflow orchestrator. But it can also be very simple. I mean, if you have some bash scripts and you tie them together using cron, that's also already scheduling of your workflows. So it doesn't have to be complicated. Data catalog, often overlooked. If you don't do this from the start, you're going to have a bad time, because then you are talking more about doing a data catalog than actually implementing a data catalog. So it holds the information about what data there is in our systems, what the data can be used for, who is maybe using the data, so if it's like a really popular data set, or maybe it's a data set that's never used, so that can be an indicator that you don't want to ingest it anymore, or don't want to process that data anymore. That's all the stuff that goes in the data catalog. So data about data in our systems. And try to get every piece of data in there. You might not know what people actually want to use, and they might not know as well, so let them find it. Programming languages, also something that we use in data engineering. All kinds of programming languages, basically. Go, Java, Python, Rust maybe, but usually Python, or Scala, which I've never seen in my life, to be honest, but other people probably have. So we use it for analysis, we use it for scripting, we use it for writing data workflows, we use it for notebooks, which is usually something that data scientists use, and we use it for spinning up data pipelines, for building all kinds of scripts around the things we do within our data engineering world. And there's lots of really, really good established data engineering and analytics libraries for both Python and Scala. That's why it's a really important, really popular language. And then there's the rest. Git, version control, CI/CD, infrastructure as code, hundreds and hundreds of databases, machine learning, REST APIs, Kubernetes, YAML, lots of YAML, monitoring and logging frameworks. This is what we all use as well. For me, a data engineer is also a data platform engineer. They're also a software engineer. They need to use correct software engineering practices, software engineering hygiene around data and around basically everything they do. And for this, you use version control, you use tests, you use CI/CD, etc., etc. And we do this to build robust systems, because that's what we want to have. We want to have a robust system for our end users. So we can supply reliable and meaningful data in a correct and timely manner. That's the thing we try to do. And in the full landscape, kind of looks a little bit like this. So this is a picture I drew of a data platform. We have our source systems, right? So it's streaming data, it's a message bus, it's a data set, it's files, whatever. And then this data goes through data pipelines. And these data pipelines run maybe once a week, or maybe they run every day or every 10 minutes, or maybe they run real time. They're actually streaming data pipelines. And our pipelines are orchestrated by a workflow orchestrator and we have data engineers and data scientists using Git, using version control, using tests, using Python or whatever tool they use to write their workflows. This gets interpreted by the workflow orchestrator, spins up the data pipelines. And the data pipelines output the data in the data warehouse. And they also output the data about the data into the data catalog. If it's fresh, we spin up the data pipeline, which data pipeline it is, where does the data come from, what does it mean, etc., etc. And then on the other end, we have the business analyst who is checking the data catalog. Hey, is there some data in there that I might use for my analysis? Yes, there is. Well, he's also writing his analytics. This is perfect world, by the way, right? It's usually not the case, but business analyst also uses version control, and they generate some dashboards and reporting that the business uses, and the business likes that because they can see that they are making more money. This also feeds back into the system. So this becomes its own data sets, its own data source. Maybe there's some dashboards and reports that we build that nobody uses. Why do we build them then? Right? This is also metrics that we can export and that we can use for analysis again. And then maybe we should just deprecate certain dashboards and data sets. And then we also have our systems using our insight. So this is maybe a machine learning framework that is serving an API that does real-time forecasting for end users, but it can also be the search infrastructure that I showed earlier. And our end users interact with this data that feeds back into the source systems. And we have completed the loop. And then we have monitoring and alerting for all components. So not just for the infrastructure components, but also for the data pipelines, also for the data itself, also for data in the data catalog, just monitor, test everything. And then this also becomes a data set with metrics and logs that we can use again. Looks really complex. It can be really complex, but with everything, just start simple. Try to keep it simple. I mean, when I started doing this 3 years ago, we distilled the use case that there was to the bare minimum. We had a very simple use case, basically, but we made sure that we have the correct base, so that we have tests, version control, CI/CD, automated pipelines, stuff like that. And then on top of that, we built our other use cases. And we kept on standardizing. And we were always very pragmatic about that. So don't optimize prematurely. Don't build use cases that you do not know are going to happen, because you might be building something that neither you or nobody else is ever going to use. So build for what you know, and build for what you know is coming in the future, concrete stuff. And develop with care. So like I said before, CI/CD tests, being a good programmer, commenting your code, commenting your data, not just for yourself, because I don't know what I did 2 weeks ago, but also for your colleagues and the people who come after you. Obligatory data landscape picture. The ecosystem of the modern data infrastructure. What you see here already is there's a tool for everything. There's a modern tool for everything that we need to do to get started doing data engineering. We have data ingestion stuff. We have the storage. And here you can see all the big major cloud providers. Amazon Redshift, Google BigQuery, Microsoft Synapse, data lakes, which is basically just blob storage with something on top. We have orchestration. Personally, it's really tiny here, but we use Airflow. It's Python. I like it a lot. We have data quality monitoring as well, so doing data tests. This is actually a really new thing in the data world. Like 2 years ago, nobody was doing data testing, or maybe they were doing it, but they weren't telling anybody else that they were doing it. Data catalog, also very important, with a bit of governance around it. So does certain data hold personal identifiable information? Maybe you should be more careful about who gets to show or gets access to that data. That's an example of having governance. Yeah, and there's also some stuff here. If it's not already too complex or too many pictograms for you, here's another. This is the data and AI landscape as of 2020. I mean, I don't even know half of the stuff that is here. but you have something for anything that you want to do. There's a product that you can use. What I think personally is really nice is this little bit over here, which is open source. And currently, open source data engineering, data analytics is really booming. For everything that you want to do around data engineering, there's a cutting edge open source project with a really cool community around it. So definitely check that out if you want to start implementing data engineering tools. Check the open source stuff that is out there. Then finally, what do I like about data engineering? I like the complexity of working with data. Because it's stateful data, because it is a lot of data, it usually becomes highly complex. You need to aggregate and combine lots of different things. Then you need to check that those things are correct, and then those things also have dependencies, and it's just often becomes a complex problem, and for that you need a complex solution. And that's what I find really interesting. Building a self-describing system, so documenting, automating, anything I like doing as a DevOps engineer, as an engineer, I can also do for data engineering. Data world is moving fast, so I used to think 3 years ago that data engineering was really boring. It's just lots of data and data warehouses and CSV files and Excel and dashboards and reports. But it's actually, there's a lot of stuff happening, and data is becoming more and more important. It's also becoming more and more ingrained in our lives. Because of that, the innovation in the data world is moving very fast. There's a lot of young people doing interesting things with data, around data. So yeah, I really like that a lot. It's multiple disciplines starting to work together as well. So something you might have seen in the DevOps revolution, which started about 8 years ago. We need to work together. Multiple disciplines need to work together. Dev and ops and the business. Data engineers, data scientists, BI specialists, developers, operations. We all need to work together, talk together, understand each other's problems so that we can build solutions that make everybody better. And that's something I really like in IT. It's about people. It's not just about tech. And I already mentioned this, but data becoming more and more ingrained in everything we do. So there's a lot of purpose there as well, especially around durability and making the world a better place. Data is very important there. Data engineering can help there. That's it.
What an excellent talk, Tim. As I already said, I'm not that technical developed. So are there any questions in the room?
Yeah.
So yeah, I'm just a backend developer, and I was just wondering.
I'm also a backend developer.
Okay, yeah, fair enough. But I'm mostly doing like unit tests and submitting a form and displaying something on a page, getting it from the database.
Mm-hmm.
So how does your typical day look like? What is a typical day for you?
Typical day looks like for me. So we have stand-ups because we work agile. We check if we have data pipelines that went wrong. If we need to investigate there, maybe there's a vendor which did not load that data or has like a really faulty API, and we need to say that they suck. But also we have maybe data scientists which have a question about some data or some analysis that they want to do, or they want to maybe use a tool that we have built. So there's some discussions about that, maybe some design sessions around building a new piece of data infrastructure. We personally, we build a lot of tools for our end users to use, and our end users are a lot of data scientists. So we also try to see patterns in the things that we do, and then say, hey, maybe we need to bring these pipelines together, or maybe we need to make them more modular. And then there's usually some time for development as well. And then I try to do some. Currently, today I've been working on implementing standardization for our streaming interfaces, so PubSub in Google, and everything around that, so automated monitoring around that whenever we spin up a new piece of PubSub infrastructure. So typical day, some talking, some team building, some designing, and some development. and hopefully not some debugging and production issues.
Okay. Any more questions from the room? Yes.
Hi.
Can you give an example of you were talking about the testing, or testing of data. Can you give an example of how you test? Do you use automated testing?
Yeah. So we, as part of our data pipelines, we have data tests. So whenever we move a bit of data around, we test that data, or at least that's something we want to do. We don't do it on all the places yet, but we're getting there. So what that looks like in our case, because you have different data testing frameworks, some of them use Python, so they want to interpret the data as something that's easy to interpret for Python. So for example, dictionaries or JSON or files. We personally use something else called Soda SQL. And like the name already says, it uses SQL for data testing. So we load data into a temporary table. Then Soda SQL tests that data based on a bit of configuration. And the configuration is YAML, because everything is turning into YAML these days. Basically what Soda SQL does is it extracts metrics from that data using SQL. So for example, a certain row count, if there are missing values, because this is something SQL is very good at. But we can also supply more complex tests. So if this field and this aggregation has this range, and this metric is this value, then it is okay or it is not okay. That's also something we can express with Soda SQL. And one of the reasons we have chosen Soda SQL is because most of our data scientists use SQL so that they can write the tests themselves.
Okay, thank you.
Any further questions? Then I suggest we should have a little break, get some drinks, and we will be back in 15 minutes.
Yeah. I mean, if you get any questions later, you can find me here and here. I'm always open to a chat or having an online coffee or whatever, so just hit me up.
Or of course on the Slack channel. Or the
on the Slack channel. Soon to be. I didn't get an invite yet. That's cool. Very cool. Okay, thanks guys.
Dat was de laatste dat ik alles iets van had.
Ja, precies. Ja. Ja, volgens mij ook. Dat is het wel voor mij hoor. Ja, ik heb nog even school, maar ik zag niet van sturen, dus staan niet voor mij worden. Ik dacht, gast. Dat is omheen. Dus het is precies nee, ze kunnen ermee overweg, ze laten ze met eruit te bellen. Soms is het wel ik kan wel het gelijk aan ik heb het best aan gehoord. Ja, dat zeggen we ja. Volgens mij gaat het door. Ik ben hier bij een andere week en ik kan ja. Ja, dat wist je ook gewoon. Ja, dus dat we moeten weer werken.
Ja, en het stuurt met zijn gestje. Waar zit je? Die scheidsrechter. Kennis hebben gewoon echt goed beheersen en ook iets goeds kunnen doen. Ja, en dan laten we nog afvragen wie is het de beste met dan zou je het probleem maken, omdat jij zelf zo ja, en kun je veel beter ja. Die is wel ja, hij had een stage gelopen, dat was hem niet bevallen. En daardoor was hij heel kieskeurig selectief in de eerste job. Ja, dus hij had zelf ook gevraagd om nog eens te spreken. Ja, zeker. Ja, het is natuurlijk wel deze tijd. Ja, blij mee.
Allemaal weer compleet en klaar voor de tweede talk. Want dan wil ik graag het woord geven aan Gert Hengeveld, die ons gaat vertellen over Storybook en waarom je het moet gebruiken. En als je het niet doet, dan ja, dat hoor je zo wel, hè, wat er dan gebeurt. Hey, veel plezier, geef me een applaus.
Dankjewel. Dankjewel. Thank you. I hope I didn't disappoint anyone. This is not about CSV, it's a new YAML. Just joking. I know, CSV is amazing, I know, I love it. I think I switched it up, I'm pretty sure. Now this is about testing your user interfaces in the real browser with Storybook. So this is something I've been working on for the past couple of months, and I'm really excited to show you this. I'm Gert Hengeveld. I'm a software engineer with Chromatic. Chromatic is an American company, it's a Silicon Valley startup. I work on Chromatic, which is a SaaS platform for visual regression testing. Basically, we take screenshots of your user interface components and compare them over time so that you don't make mistakes. So you change some styling somewhere and it bubbles up somewhere in an unexpected place. We will know and show and tell you that you made that mistake. But we also work on Storybook. Chromatic is built on top of Storybook, and so Storybook is very important to us. Storybook is actually an open source project, and we spend a lot of time improving Storybook as well. If you'd love to know more about that, follow me on Twitter. I occasionally send tweets about stuff like that. So, user interfaces these days, in case you're not familiar, not aware, are built using components. All of the major front-end frameworks or libraries, such as React, Angular, Vue, they all use components as the base node, so to say, in the entire structure. You then build up your user interfaces from those components, and the whole idea there is that components are reusable. So you have to spend less time reinventing the wheel all the time because you can reuse the same component over and over again. Even classic server-side frameworks such as Ruby on Rails and Laravel, they all are also jumping on this component-driven development bandwagon. And a big part in this whole ecosystem is Storybook. But before I dive in there, I want to talk about the state of UI testing. So user interface testing it's really hard, and the problems are that your app that you might be testing, it's got some data, loading data from a database or data warehouse even, and that data can be flaky. It might need data to send data over the wire, and what's more is reproducing a certain state in your app is pretty hard to do. You have to deal with complex business logic. Your components, like front ends and user interfaces are getting more and more complex all the time. More and more stuff is happening in that front end these days because people expect rich user interactions, right? But testing all of the various states that your app can have is very challenging, and it's something that you definitely don't want to do manually. And we are dealing with the wrong tools. There are tools to test user interfaces, and in fact the front-end framework authors are doing a really good job to try to make it easier as they go along and release new versions. And there are systems in the ecosystem to allow you to test those user interfaces. But it's kind of weird that the status quo of testing user interfaces or user interface components is actually to test them in Node.js with JS DOM, which isn't actually a real browser, which is kind of weird because your user interface components will end up running in the browser or on mobile, but that's a different story. So Storybook, that's where Storybook comes in. So Storybook, in case you're not aware, Storybook is a tool for building front-end components, for building UI components faster and easier. The way it does that is it allows you to build user interface components in isolation, meaning you can focus on that one button that you are building, or that one form that you are building, or a single page that you're building. But the gist is you don't have to deal with the surrounding state of an application wherein that component is eventually going to live. It allows you to organize your work by cataloging all the various components that you have in your system and all of the states that those components can be in. You can use Storybook to test and document your components so that it becomes they are more resilient to change and they are easier to reuse by other people on your team or other teams even, or maybe even people in the world. So take for example Stripe. They release user interface components that other developers can just drop in their web app so that they can enable payment in their system. Obviously those components need to be really battle hardened and tested and documented so that they are integrated in other people's apps correctly and reliably. And finally, Storybook allows you to improve the workflow that you have with your team. So that means collaborating with designers, collaborating with backend developers, collaborating with other stakeholders, management, etc. And the way that Storybook does that is by enabling you to build those components in isolation. So you don't need to look at this code example per se, but what's important here is that this is the user interface of Storybook. Storybook just runs in your browser, and the canvas here is where your component is going to live. So that can be anything. And the great thing about it is it's basically just an iframe, so you have complete control over the page and the data that the component receives, and that is the whole idea behind Storybook. You put basically user interface becomes a function of just data and the template or the component logic, and there is no way less context that's relevant here. And cataloging variants and states is a big deal in Storybook. That's basically what it's all about when you build a Storybook. And you might think, well, why would I want to do that? Why would I want to catalog variants and states? What does it even mean? Well, before I get into that, know that thousands of teams across the world use Storybook. Storybook is not a new thing. It's been around for many years, and it really is used by the big names. So all the names you see here, they have published storybooks. They use this to collaborate within their teams, but also to the outside world. Some of these, or many of these actually, are open source. So if you would want to build a website that looks like a BBC website, you can use their Psamia design system and build something that looks exactly like a BBC website. But the same thing goes with all these big things. But variants, right? So what does it even mean? So comparing component variants is what we call stories. Stories is the leading concept the main concept in Storybook, hence the name Storybook. But what are stories? So they're variants of your component. What you can think about there is states. So say you have a user interface component, it might be in a loading state because the data isn't there yet. It might be disabled, in progress, it might be an error. But there's also functional state, right? So have a toggle switch, and it can be on or off, or a collapsible component can be open or closed, whatever, right? A modal can be open or closed, or whatever you concoct in your user interface. But that's not all, right? You have to deal. You can deal with the edge cases, right? I have very long text or no text at all, big or small images or extreme numbers. What happens if I throw €1,000,000 in my shopping cart? Does it work, right? Does it overflow weirdly? Does it no longer print the last remaining zeros, right? Maybe that breaks, and people would be checking out way more money than they think they are, right? Missing data, so there something might not exist that you expect there to exist, or special characters, of course, right? Different languages, whatever. If you put Russian in there, does it still work correctly? Or right to left text, right? Things like that. So if you want to build resilient user interfaces, you need to deal with all these situations, right? Especially if it's going to be a component that will be used in all kinds of systems that you have no control over or limited control over. And then finally there's context. So I mentioned you want to eliminate context in Storybook really, but still your user interface components will need to be designed in a way that they take that into account. So a user might be signed in or signed out. They might have a different language than English or Dutch, right? They might prefer a dark theme these days on their computer, right? Do you design your user interface components to deal with that? Maybe. Or they might be on the left or right-hand side of an A/B test. And then it gets more complicated because there can be countless combinations of all of these things, right? Of course, you don't want to model out and write down all of the various combinations. It gets unwieldy, right, and close next to impossible. But certainly there are logical combinations that make sense in the context of your system, your application, right? That you should actually document and spec out. So speccing that out is where component story format comes in. Component story format is an open specification pioneered by Storybook that allows you to define these stories. I'll show you an example in a moment. But what's great about component story format being an open specification is that more and more tools are actually adopting this standard. And that means that not only can you use it in Storybook, you can also use it to test with Jest or throw it into Axe for accessibility testing and all that sort of thing. And the reason that's super easy to do is because it's basically vanilla JavaScript. There is no special syntax, weird syntax. It's just JavaScript or TypeScript if you prefer. So here's what that looks like in just vanilla JavaScript. Say we have a badge component. It's like the most boring component I could think of besides a button. A badge is basically like this pill-shaped thing with some text in it, right? Or a number often. So say I have a badge that says hello world, and the way that the story specification works is typically you have the component name .stories.js or TS as the file name, so it lives beside the component file itself, right? It's a sibling to the other file. You import the badge here because that's the one that we want to write a specification for. We say this is a component, and we specify some metadata is the default export in this file. So, and that's just it's just an object. So there is again no special syntax here. It's just a JavaScript object that we happen to export from this file. In this case, I'm specifying some arguments because it needs a label, and I don't want to repeat that label each time. So it's just going to be hello world. And then this component happens to have two variants. There's a big one and there's a small one. And for both of those, I'm writing a story. So I have two stories, a small story and a large story, and really the only difference between them is the property size that they receive. Right, so I have a small one and a large one. It's pretty simple. Again, plain JavaScript, so you can import it in wherever place you want, and a lot of different systems support this out of the box. What's new in the latest version of Storybook that we are releasing Storybook 6.4 are interactive stories. So what's an issue with the situation that I described before is that you can't always specify a component state using just those args, right? Just data. Most of the time, that is preferable, right? I want to pass data into my component, and that makes it render in a specific way. But sometimes you have a user interface component that requires the user to type in some text into an input box and then click a button before it does something, right? Not everything can be expressed in data alone. So that's what interactive stories are about. A lot of people in the community struggled with this, and so we went ahead and built something for that. So that's what a new concept in the latest version of Storybook is the play function, and I'll show an example in a moment. That allows you to define stories for more complicated components. Say you have a component that is nested inside another component, or you even have an entire page, right? You might have a web application or website, and you're building complete pages in Storybook. That's done more and more these days. But of course, a page is built from a bunch of other components. Well, what if I want to change some information on one of those components? Reaching and putting in data into the page does not necessarily trigger the component in a certain state. So that's where indirections will help. The way that we do it is by simulating user behavior in the browser. And we didn't invent any of this. In fact, we're building on top of the shoulders of giants here. People in the front-end development world are likely familiar with testing library. So testing library is the most popular choice these days for unit testing UI components. And we are just bringing that experience of using testing library for testing into the browser. And that will unlock a whole bunch of very interesting things. What we're also working on and releasing soon is an ESLint plugin to make it super easy to write this stuff so that you don't make mistakes. So let's dive into some actual code. So I'm going to be programming here for a bit, and I want to show you what that looks like. Actually, I should drop this code, but you shouldn't be seeing it yet. A bit more. Let's hope that still fits then. There. Fine. So what I've done here is actually should save my file, of course. Right. Empty state. I have prepared an example component, and it happens to be a sign-up form for something, right? The Storybook community. It asks for an email and a password, but this happens to be a component that I cannot control by passing in props, knowing I have to actually interact with this form in order to be able to submit it. So what I'm going to be doing is I want to write a story with the state filled in, right? So the way that we do that is we write a new story, which is basically an export of a const state filled, and the story here is just a JavaScript object. For people who are already familiar with writing stories in Storybook, this syntax here is slightly different than what you're used to. This is component Storybook story format version 3, which is coming. Actually, you can already currently use in the latest version of Storybook, but will be the new default in 7.0. But I'm using it already because I want to be using the latest and greatest, of course. So what we do here is we define a story called filled, and if I just save this, by the way, you'll see there's a new story here. So I'm going to click that, and nothing happened, right, because it's also empty. I want to define a play function, and a play function is just an async function. In this case, it's an arrow function that I define as a property on this object. And now, inside this play function, I can start to create user interactions. So what I want to do is I want to type some text into that email field. For that, I'm going to pull in testing library. I don't want to write that stuff all out, but this is what that looks like. I'm importing user event wait form within. You'll see what I need them for from Storybook/testing library. If you happen to already know testing library, of course, Storybook/testing library is not the official original testing library. It is our wrapper around their library. So that's also an open source thing, right? We just wrap it, and you'll see why. So I'm importing that, and in my play function, first off, I want to start by targeting the story canvas, right? That's that area here. The way that I do that is I can retrieve the canvas element from what I receive on my play function, and then const canvas equals within the canvas element. Canvas element. Right. So, and then I could say user event. That thing is super obnoxious. User event dot, yeah, that's because of the screen resolution. You know what? So, user event dot type, and I want to type into an element, right? So that element I can select using canvas dot get by something. There's various options here. I'm not quite sure how I want to retrieve this element. So what I'm going to do is I'm actually going to bring up my DevTools here, inspect this element, this email field right there, and look at the DOM structure of it. And it seems to have a data test ID, email. Right, I guess I can use that. So get by test ID. It exists. Email, right? Email. And I'm just going to type in a value saying hello, and see what happens. There you go. Right? It just refreshed automatically. I saved my file, refreshed automatically. Bam. Hello is over there. Actually, now I can put this thing that side. That's a great thing. Go there. Side by side doesn't really work. It turns out. So I want obviously also want to type in the other one. So I'm going to say user type into the what's it called? Inspect password. Obviously. World super safe password, right? And bam, it's filled in. Great. What's interesting here, you also see that the stuff that I've written in code is also displayed here, right? So this is the interactions panel. That's the new thing with the interactions add-on that we're introducing. You get this panel, so that makes it much easier to debug these tests that you're writing. So, and that all just runs in the browser. There's no special software involved here, so in case you happen to know Cypress, you don't need to install any stuff like that. You just get it in your browser, right? But basically it's the same thing. And this is what I get when I fill it in. Let's see what happens when I click this button. Oops. So obviously my email address is invalid and my password is also invalid. Right? I can actually hover over this thing here, and I need minimum 6 characters. But this is interesting. This might very well be a state that I want to test, right? Because this is a distinct state in my application that I want to know what it looks like and verify it in the future that it doesn't break, right? So what I can actually do is also start writing a story, export const invalid, that tests that particular state. So the way that I do it, I write a play function again, async arrow function like that. It receives the context. In this case, I'm not going to destructure it. And what I can do here is I don't want to repeat myself, right? I don't want to write the same code again. But this being vanilla JavaScript and all, I can just do filled dot play, give it the context, and of course I have to await it because it's a promise, right? It's an asynchronous function, which reminds me I forgot to put the await over here. It worked anyway, but it's important. and carry on doing my thing. So I want this context canvas element, and now I want to click that button, right? So I'm going to say await user event, click, no, not clear, click on the button canvas. Get by role. Huh. Button. I want the button, but whichever button. Give me the first one. Actually, probably might not work. Let's see what happens. And see what that. I got a new story, invalid. Run it. Oh, boom! It's failing. It's failing. Why? Well, I found multiple elements with the roll button. Right, the reset button. Thought that might happen. Name. Well, it just takes a regular expression, so create, whatever, something that contains create. Click it. Boom. So I have a story now that when I run it, I can refresh it in case you missed it here. It actually clicks that button, right? And then that triggers the error state that I've seen before. I no longer need to manually click it. It's just created it for me. Let's see what I can do with this thing, right? You can also hover over this thing to show the tooltip. Well, totally we can do that. Await user event, hover over canvas, get element by, I don't know, what's this little thing here? Oh, it's got a data test ID. Copy it, get by test ID. There, boom, hover it. Does it work? No. Unable to find. Oh, right. So this is an interesting situation. This is pretty common when you write tests like these against a live component, right? You interact with it, but sometimes you expect something to be there and it's not there yet. It's going to be there, but it's not there yet because the button click triggered some process that takes a couple milliseconds and then comes back, right? Promises, asynchronous processes. So what we can do there is we can actually wrap this piece of logic into what we call a wait for, which takes a function and then we can invoke it. Does it work now? Does it work now? Bam, it worked. What you actually saw for a brief moment there. When I refresh it, can I trigger it? Well, slight brief moment, it's red, right? And then it turns green. So what it does, it fails initially, and then it tries again, and then it succeeds. So that's what the wait for actually does. This is not something that's new. This is part of testing library. I did not invent any of that. This is just the way it works. So now I can actually test also that hover state so that it shows my minimum 6 characters requirement. So far I'm pretty confident about it. I'm pretty happy with this. So let's jump back into my slides and look at this. So to recap first, this is what in essence it looks like to write an interactive story. Right? So we have our metadata there, we have our play function here, and we're simulating some events on the canvas, right? And what's important to note is that you need to use the Storybook wrapper for testing library, because that is what enables this panel, this debugger, to show the interactions. What's more, and what's actually coming in the near future, is interaction testing, to make assertions about the state of the component, and that being jest compatible, so people who are already familiar with jests, it's the same syntax. In fact, it is jest. We bring an in-browser debugger. You've already kind of seen it. But also a Node.js test runner, so that you can run these tests in a continuous integration system, or on your local machine, run all the tests, and reproduce any errors by getting just a URL. And you can, in fact, send that URL to a colleague, and they should be able to reproduce the error as well. Let's jump back. Continue down this road. What I actually now want to do is make some assertions about the state of my component. So I'm also going to create a new story for the actual success situation, right? So export const submitted. So where it did submit, play an async function. Again, could copy and paste this, but good type. In this case, I'm just going to copy and paste rather than use the previous one, because that one was not what I wanted. Give me that canvas element, and now I'm just going to say shared at chromatic.com, right? A valid email address and super secret password, right? And now I will submit it. So click that button down there. Click it, and I'm not going to do the hover thing again, but now actually I got a submitted thing, and you see it clicked the button, it started spinning, and oh, it's done. This is an animated component, right? It does something when it's submitted. It just happens to do that. What I can also do is actually expect, which comes from jest, expect args.onSubmit. I need to grab args to have been called. People who know jests and write unit tests like that, they are probably familiar with to have been called as a way to assert that a function has been invoked, right? So what's this thing? So my component that I just defined up here, that component takes an onSubmit callback function. And what I did is through metadata, I said this onSubmit is an action, which is a concept. It's actually another add-on in Storybook. You can mark something as being an action. And there's this tab here, actions, where you can see the log of all the actions that have been invoked. And what I need to import it, of course. Let's fix that from @storybook/jest. So I've marked it as being an action, and that puts that invocation in the log, but I can also just make assertions about the fact that it was invoked. The reason is that anything that's marked as an action, we are automatically creating a jest mock function or spy for it. There is no setup involved beyond marking it as an action. It just works. So that's pretty cool. Jumping back into my interactions, I can assert that when I run it, it should have been called. Didn't. Async. Oh wait. Wait for. Same situation, right? I'm using a form library, Formic, and it does asynchronous validation. And that's why it takes a little while for it to trigger the onSubmit handler after you click the button, right? So I just wrap it in a wait for, and I expect it to have been called. Does it work now? Bam, it works. You can, of course, you can assert the arguments it has been called with and such, but now I can actually test and verify that my component does what it's supposed to do. I could even go further and now make assertions about the fact that this text appears on screen, for example, or that there is a back button and that it does what it's supposed to do. In fact, good practice there is to create a new story for that. Use this play function composition, aka invoking the play function from a previous story and a new story, so you don't repeat yourself, and then write some additional assertions. So you have separate stories for those separate steps in the workflow, so to say, this wizard of sorts. Right. So again, to recap, what this gives you is assertions, automatic spies on any actions, and again, it's important that you use the Storybook wrapper for jest. What I totally forgot to show you, which is maybe even more interesting, is what you can do is click one of these things here, and it'll pause right at that step, right? It has paused this step of interactions right at that point, And I can, of course, use my dev tools as a one. Like I'm just looking at the current state of the DOM here. I can make do all kinds of checks. Like my test is, my interactions is failing. Why doesn't it work? Something changed? What changed? Oh, the test ID has changed. Maybe, I don't know. So you can step back and forth through this list of things. I should not have done this because this is a running bug, but it's experimental software, right? But you get the gist, right? You can click through these things back and forth, run to the end, rerun it, what you want. And that is what it makes it super powerful. Alright, so maybe by now you're wondering how did they pull this off, right? Well, magic. No, it's not magic, of course. So what we're actually doing is runtime introspection and interception. That might sound like what? Basically, you call that function, we call through to the original function by testing library or expect. But we also log the fact that you did so and send an event to the add-on panel so that it can show it in the log. So that it's tracking the methods those method invocations. And then when you are debugging or stepping through, it actually returns, it just intercepts that function. It doesn't run the original function that you wanted to run. Instead, it just returns a promise. And that promise will not resolve until you click next. So that's what allows us to pause in the middle of running that play function. And which is also the reason why you need to put the await keyword in front of each of those things. That is a minor nuisance that you need to await them, but really, I think it looks kind of clean too. And then there's a final trick in that when, say you are paused in the middle of a play function, and you switch to a different story, what you want to do is abort the currently running play function altogether. Don't run anything what comes next. Well, how do you exit a running function in JavaScript? You throw, right? So what we do, we throw, but we don't want to show like a huge error on screen, boom, it blew up. So we actually throw a specific type of silent exception that is caught by Storybook. As a general concept, that's in the core of Storybook now. And it catches that exception and basically it logs it, but doesn't do anything other than that, right? It doesn't show a big error on screen that it would otherwise do. Let's look at how we are doing on time. So it's 9, so I'm just gonna carry on. So coming soon is, like I mentioned before, is this test runner for Node.js. Because obviously you don't just want to run tests in your browser alone, right? You want to develop those tests in your browser, be able to debug them, etc. But of course the functionality of tests is that you run them continuously in an integration system before you push to production, right? So the test runner that we're working on, basically what it does is it takes those play functions and converts them into a jest unit test that you can then run in a CI system, and that tests across all the stories in your entire storybook rather than just the one that you happen to be looking at. It runs locally or in CI using a headless browser. And then you can actually, when it throws an error, this is a random screenshot, not the actual thing, it gives you a URL that you can click to show the error in a real browser rather than a headless browser so that you can debug it again. And finally, we are building in reporting so that you can integrate it with other tools. So, for example, in Circle CI, you will see a nice list of errors rather than mumbo jumbo that you see over there. So, to wrap up, stories, in a way, in Storybook have always been tests, right? Writing out a specification for what your component can do, and then basically looking through the components that you have is a way to test them. But visually inspecting whether a component looks right is just one piece of the puzzle. right? And visual testing is what Chromatic does, by the way. We take those screenshots, remember? And then we compare them pixel by pixel over time. So that's covered. But what we are working on, and the first step there is interaction testing, is way more ways that stories are tests. So accessibility is something that there's already an accessibility add-on in Storybook, but reporting on those things in your CI environment is something that's coming in the near future. Composition, so of course components are composed out of other components. We want to test those things. And entire user flows, you've seen some of that already, right? Basically a sign-up form is a flow in a way. Right? So that is all getting unlocked with interaction testing. And if you would like to know more about this, follow me on Twitter. I occasionally tweet about these things. And thanks for your attention.
Hello, it's me again. Are there any questions? No one has any questions? So it must be a perfect talk now.
I was completely clear. Yeah.
Very
Some
nice.
People are scared. Oh, there's one.
Oh, sorry, there's one question.
So the test ID attribute, that's inherent to Storybook then, or?
No, it just happens to be in this component.
All right.
So, in fact, testing by retrieving an element by test ID is a bit of a hack. There are the best practices there is to pick something that's stable, and the test ID is of course stable. But you like using a button label is slightly less stable, but might be more resilient to change anyway. So it depends on the component whether or not you are using those attributes. But getting it by a role, for example, is a pretty good way to go about it. And it's actually, so Testing Library has a ton of recommendations. They wrote articles about it and how to do this type of testing reliably, so that when you refactor some code or you change the looks of your component, that your test won't break, right? And Test ID is one trick in the toolbox.
Okay, thanks.
Any more questions? No, then I would like to thank both of the speakers for their amazing talks. Tim, if you can come forward as well. So yeah, it was an amazing evening. It was nice to have you all back at the office at DEA. Thank you very much for having the talk.
Thanks.
You as well. And we also have something to enjoy the evening, because you were talking, so you didn't have a lot of chance to have a beer.
And didn't drink nearly as much beer as the rest of us. Yeah.
Yeah. So tomorrow I will send you all a type form. It would be much appreciated if you fill it in, so we can improve our meetups and also give some feedback to our speakers. For now, it's all I can say is have a drink and a chat about the interesting talks. So thank you guys again.
Thank you.
Have a great evening.
Thank you all. So now for that CSV talk. Thank you. Thank you. Thank you.